So this video is about solution of partial differential equation. A PDE looks like something in the left hand side is equal to 0. The left hand side contains terms like x, y, z, p and q. Why? Because we are talking about first order partial derivatives only. So the equation, if we name it as 1, is a partial differential equation of first order. And if we want to find the solution of this, then we can write phi of x, y, z is a solution if it satisfies f. Instead of writing phi of x, y, z is equal to 0, by implicit function theorem we can also write z is equal to a function of x and y. So if we find z, then we are ready to go and find p, q, because p is the partial derivative of z with respect to x and subsequently q is the partial derivative of z with respect to y. And we can input the values of z, p and q from here by finding z and say that 2 is a solution of 1. This z may contain arbitrary constant or it may not contain arbitrary constants. Based on these things, we are going to classify the solutions that we are finding in first order partial derivatives. First order partial differential equations, which involves first order partial derivatives. So the classification goes like, the first one is called complete solution, the second one is general, the third one is called particular solution, and the final one is called singular solution. So keep in mind that if you have a function of x, y, z, p, q is equal to 0, then we say a solution z, because z will represent something in terms of x, y, some arbitrary constants a and b. On that case, we say this z is a complete solution. It is called a complete solution because it completes all the spaces of x, y, a and b. And anything which misses anything from x, y, a and b, that comes under the rest three categories. So what is a general solution? If z is equal to a function of x, y, but here we are eliminating b, so we are writing b as a function of a. On that way we can eliminate b and say that z is a general solution for the partial differential equation this. Now what is the particular solution? If this a is of our choice in general solution and a and b are of our choice in complete solution, then we say that the solution is a particular solution. And now what a singular solution is? A singular solution is nothing but a solution which is free from the arbitrary constant. You can also write z here. You can also ignore it and just write x and y. So this is a broader classification of solutions of PDE for first order PDEs. Now complete solution also satisfies the thing that you find a matrix A and you find fx, fy, fxa, fxb, fya and fyb, and the rank of this matrix is 2, then you say that the solution is a complete solution. And now what this f is? If you represent z minus phi is equal to f, then you can differentiate f with respect to x, y, xa, xb and so on, and you can find it. So if you have a confusion of this f, then I can write g here, where g is nothing but z minus phi here. But you are not going to see how this rank is 2. So a clever way of noticing that a solution is complete solution is, you can see the number of arbitrary constant is equal to the number of independent variables. Like in this case, we have two independent variables, say x and y, and we have two arbitrary constants a and b. So we are saying that the solution is a complete solution. We can go on detail about each solution, but I don't think that will be fruitful as of now. So we'll be discussing how to find the solution and the methods involving finding solutions.